I uploaded a screenshot of buggy Python code and asked it to find the problem. It spotted the bug immediately. The assignment operator was reversed, total equals plus n, so the running total was reset every iteration. Gemma 4 caught it, explained it, and gave the fix. That's multimodal code debugging in 24 seconds. Now let's dig into what's actually under the hood. All three models got it right. But look at the speed. Flash solved it in 5 seconds. Gemini Pro in 16. Gemma took 24 seconds and generated twice the tokens. On a simple task like this, Gemma gets the job done. The question is, what happens when we push it harder? Google just released Gemma 4, two open-weight models that are genuinely competing with the best proprietary AI in the world. The 31B dense and the 26B-A4B mixture of experts. We're putting them through 8 real-world tests: JSON, code, vision, reasoning. Can they actually handle production workloads? Let's find out. First, let's understand what we're working with. Gemma 4 comes in 2 flavors. The 31B dense model uses all 30.7 billion parameters on every single token. It's the heavyweight. Maximum quality, maximum compute. The 26B-A4B model is a mixture of experts. It has 25.2 billion total parameters, but only activates 3.8 billion per token. That means near 31B quality at a fraction of the compute cost. Both are Apache 2.0 licensed. Completely free. You can self-host them, fine-tune them, or run them through Google AI Studio at no cost. Here are the official specs straight from the Google DeepMind model card. 2 things worth calling out. First, the 31B dense has no audio encoder, text and image only. Despite what you may have read elsewhere, audio is not supported on these 2 models. Second, the 26B-A4B runs just 8 active experts out of 128 total, plus 1 shared expert. That routing mechanism is why it delivers near 31B quality at 4B compute cost. And this chart tells the whole story. ELO score on the y-axis. Total model size on the x-axis. The Gemma models sit in the top left, the efficiency sweet spot. Frontier-level performance at a fraction of the parameter count of everything else on this chart. Now let's see how they compare to the big proprietary models. Here are the benchmarks. On AMA 2026, the math benchmark, Gemma 31B, scores 89.2%. That's impressive. But Gemini 3.1 Pro hits 95.6%, and Claude Opus 4.6 reaches 94.4%. On SWE Bench Verified, the real-world coding benchmark, Gemma 31B gets 78.8%. Gemini 3.1 Pro gets 80.6%. Claude Opus 4.6 leads at 80.8%. Extremely close. But here's where the gap becomes obvious. On humanity's last exam, the hardest reasoning benchmark available, Gemma 31B scores 19.5%. Gemini 3.1 Pro scores 44.4%. Claude Opus scores 40%. That's a 2x gap on the hardest problems. The takeaway: Gemma 4 is close to frontier on standard tasks, but deep multi-step reasoning is still where proprietary models pull ahead. The researchers call this jagged intelligence. A model can solve a gold medal International Math Olympiad problem, but still struggle to read an analog clock correctly more than 50% of the time. So let's stop looking at tables and actually test this ourselves. Text tasks, multimodal tasks, and complex tasks, starting easy and pushing until it breaks. Test 1. Simple JSON extraction. We give it a block of unstructured product data and ask for a clean JSON output. This is the bread and butter of any LLM. Both models nail it. Clean structure. Correct keys. No hallucinated fields. For tasks like this, Gemma 4 is production ready. Test 2. Write a single Python function. Email validation with regex. Again, both models produce clean, working code on the first try. The 26BA4B responds noticeably faster, which makes sense. It's only activating 3.8 billion parameters. For single-function coding, the speed advantage is real. Test 3. Simple reasoning. A three-step logic puzzle. Alice is taller than Bob. Bob is taller than Carol. Who is shortest? Both models answer instantly and correctly. So far, a perfect track record. Now let's move to something more interesting. Multimodal. Both the 31B and 26BA4B support image input natively. Text and image. That's it. No audio on these two models. Test 4. OCR and table reading. We upload a benchmark comparison table. 6 models, 12 benchmarks, 72 individual data points. We expected errors. The visual token budget is a known limitation. Models often get the trend right, but miss exact values. So we were genuinely surprised. Gemma 431B extracted all 72 data points correctly. 0 mistakes. The vision encoder is clearly stronger than we assumed going in. Test 5. Image Q&A. We drop in Cloudflare's composable AI architecture diagram and ask the model to explain each layer, the composable approach, and identify the main risk. It nails it. All 4 layers correctly identified, composable redundancy explained. For the main risk, it spots that the compute provider is a single point of failure. Every request flows through it. Then unprompted, it adds multi-hop latency as a second risk. That's senior engineer level analysis from a free open-weight model. Test 6. Multi-file architecture. We ask the 31B model to generate a full-stack to-do app. Fast API backend, React TypeScript frontend, 6 files, auth, and database. Types and API contracts need to align across all of them. Honestly, it surprised us again. All 6 files generated in one shot. The TypeScript types exactly match the Pydantic schemas. All endpoints exist and align with the front-end calls. CORS is configured. The SQL Alchemy relationships are correct. There are caveats: simplified auth, a deprecated fast API startup event, and no bcrypt on passwords. But for a prototype, this works. It took 110 seconds and nearly 3,500 tokens, but it held the full architecture in context. Test 7. Deep reasoning. 5 people, 5 jobs, 5 pets, 5 floors, 10 interacting constraints. We expected the chain to collapse around step 9. It didn't collapse. It solved it. Then it kept going and found that the puzzle actually has 2 valid solutions. It verified both systematically against all 10 constraints and presented both answers. That's not a lucky guess. That's real constraint satisfaction reasoning. It took 203 seconds and nearly 6,000 tokens, but it found something the puzzle designer probably missed. Look at the numbers. Gemini 3.1 Pro solved it in 96 seconds using just over 1,000 tokens. Gemma without thinking took 204 seconds and nearly 6,000 tokens. Gemma with thinking mode pushed to 234 seconds and over 6,000 tokens. All 3 models arrived at the same correct conclusion. The puzzle has 2 valid solutions. Gemini was far more token efficient, but every model was honest enough to catch the ambiguity rather than forcing a wrong answer. Test 8. Complex nested JSON. We give it a patient record and ask for a deeply nested schema with over 30 fields: addresses, insurance, visits, prescriptions. Both models nailed it. 100% correct JSON, valid syntax, correct types, correct nesting. The only difference? The 31B kept the middle initial in the first name field, while the 26B dropped it. That's a judgment call, not an error. No hallucinated keys. No dropped brackets. No type errors. Both finished in around 40 seconds. For structured extraction at this complexity, Gemma is production ready. So here's the honest verdict. Gemma 4 passed 7 out of 8 tests. JSON extraction, structured output, reasoning, vision, even deep logic. It handled them all. The only test with real issues was multi-file code generation, where it mixed Pydantic versions and used deprecated APIs. Where proprietary models still lead is efficiency and polish. Gemini solved the same reasoning puzzle with 6 times fewer tokens and twice the speed. And for multi-file production code, you still want the code quality that comes from larger models. But the real story is the trajectory. A free, open-weight model just passed 7 out of 8 real-world production tests. Not benchmarks, actual JSON, code, vision, and reasoning tasks. That was unthinkable 18 months ago. All the source code, test prompts, and full model responses are linked in the description. Check it out and run the test yourself.